In this video we'll cover faster cycles rendering with K-cycles and the new performance update plus Ultra Denoiser. In addition, there is speed rendering information that applies to regular cycles. K-cycle has a set of performance features and options for improving viewport and final rendering. The options affecting cycles performance are easily available and controlled from the K-cycle sections. The Ultra Denoiser can improve rendering time by using less render samples compared to the standard denoiser to have the same scene texture and geometry detail and image quality especially noticeable at low render samples. Here is our latest performance chart comparing K-cycles to the same cycles build of Blender using the default cycles final render settings of a noise threshold of 0.01 and samples of 4096 without the denoiser with an RTX 3090. So when you first load K-cycles, you'll see a K-cycles section, and all your first settings that you see in these sections are related to performance. You have a K-cycles mode, GPU boost, global illumination presets, sampling presets, and extra viewport update and navigation. For K-cycles mode, we have none. Basically, we don't use a performance mode. Fast will give you the highest performance possible by speeding up the sampling and maintaining good quality on the image. Standard is a little bit less performance, but in some scenes it could be higher quality. And premium will be even slower rendering, but potentially higher image quality in certain scenes, or don't use it at all. But you still get some performance improvements due to some of the other optimizations like GPU memory and other updates in performance. The next is GPU boost. It uses more GPU memory to improve your rendering performance. It is more useful with RTX cards. We have the auto mode, decides depending on your graphics hardware the best mode to use. We'll have max, we'll use the maximum amount of memory and maximum possible performance. A little less memory. Low is slightly more memory than no memory at all, but give you some boost. None is no extra memory at all. So you need to save memory and you tight less memory than actually the default Blender. Typically auto is a good setting. Depending on your scene you can try different settings. And then we have the GI presets which control the quality of your lighting in your scene. And obviously the higher the quality of your lighting, which means more bounces, the longer the render is going to take. User settings allows you to just use your own settings, and then you'll have the presets for the highest quality, which is high, and slower render. Standard, a little bit less quality on lighting, but faster render. Low, less quality on lighting, fastest render, and lowest will get the fastest possible rendering with the lowest lighting quality. Sampling presets get the most performance gains, but at the expense of noise. User, that doesn't apply any presets, and it's up to the user to set up his own settings in the sampling section. Final high will have the settings for the highest quality on the sampling, the least amount of noise, but the most rendering time. Final settings for final render, but if you do an animation you may want to even go to final high. Medium, you get less quality, more noise, faster render. And then you'll continue all the way to draft. To the lowest will give you the least amount of samples and the highest amount of noise. And then these lowest ones, having a good denoiser is critical to have a decent quality. That's Ultra Denoiser comes into play. The last setting we're going to look at is called the extra viewport updates and navigation. It reduces the viewport updates for faster rendering while you're modeling or moving objects. It's recommended to have this one on, and when you just have a static viewport and just changing materials or different types of rendering settings, this one setting off for faster rendering in the viewport. Let's do a K-cycles render and compare with the vanilla Blender on the same exact scene with the same settings. Loaded this choke of fur, interior scene 1. I'll be using fast mode, boost max. Auto should work almost exactly the same or really close. We'll set the settings to the final render settings, which are 0.01 noise threshold, max samples of 4096. So let's do our test render. So the render just finished on a time with 2 minutes and 31 seconds. Let's try exactly the same scene with the same settings with the default Blender. So we load the same photographer interior scene, number 1. I go to the sampling on the render settings, For the final render, I'll check this, turn off the denoiser since I just want to test the rendering alone, and we have the same 0.01 noise threshold, max samples of 4096. Do our test render. Now Blender's render has completed on a time of 3 minutes and 32 seconds. This must surmise our render. Let's do the same thing. K cycles. Let's compare. Look at the top. Look at the K icon. That's the image quality for K cycles. With 2 minutes and 31 seconds, we can switch it to Blender. 332. Now K cycles. Blender. Time difference on the top left corner. Now let's try a simpler scene, drone scene. Product design, scene that a lot simpler than the interior scene that we did previously. Let's make sure we have our K-cycle mode to fast, boost to auto. Let's make sure we have our final rendering settings, 0.01, 4096. And let's do a test render. Goes render finish in 12 seconds. This is a scene that was given to me by a customer called Soma that he wanted me to improve the K-cycles performance. Let's try the same scene in the vanilla Blender. Downloaded the drone. Make sure we have final settings. Turn off the denoiser and let's start the render. So vanilla Blender just finished with a render time of 20 seconds. So that's a pretty nice improvement of almost from 20 seconds to 12 seconds, that's 40%. So that definitely can save a lot of rendering time, especially when you're doing animation. Now we're back to our interior scene number 1 from Chocofer. We're going to be testing the global illumination presets. We'll do a render of each setting and see the benefits versus quality for each setting. And let's do a sampling of medium to save some time. So I finished all the rendering presets for global illumination, and we have illumination high to a minute 18, the most amount of light. Standard slightly less, down to a minute and 5 seconds. Low, noticeably less light to the much less bouncing in the diffuse and glossy areas. 49 seconds, and then we get the lowest, which it drops all the way to 28 seconds, but lighting quality is considerably, but the times are dramatically shorter compared to high. So standard, low, and lowest. Global illumination presets are really convenient, quick to use, they're non-destructive, you can switch back and forth, and you need to optimize the scene to a higher degree. Definitely you should go to the light paths, preview mode, and make sure we back to user mode. Be actually using the settings of the light path. Focus in the amount of bounces, usually diffusing glossy icon to give you the most effect on the lighting. Let me set up a little bit better the preview mode, and we can set up the denoiser also. So obviously if you go down to 0, considerably darker on the diffuse, glossy, you can set up something like this, and this will be obviously a lot less time. When you're working with presets or settings that have very low bounces and the scene is a little bit too dark, you can compensate using some tone mapping. This example, I could use the post effects tone mapping, and then I could adjust basically some of the shadow areas. As you can see right away, you can compensate some of the exposure, and you can bring quite a bit of light. And of course, some of the shadows are not going to be fully light up just due to the limitation of the bounces, but definitely more usable in case you really need to use global illumination as an extra control in your rendering. Let's do the same test with sampling presets. Will give you the most amount of rendering savings at considerably more noise. So the rendering for all the sample presets are done, and let's start looking at the results. And we start with final high. We got 2 minutes and 53 seconds. All these images are done without the denoiser. Low level of noise. Final, slightly more noise. It's hard to tell the difference unless you zoom in really close, and probably harder to tell with the YouTube conversion, but there's a slightly higher level of noise. And the time went down to 2 minutes and 33. Medium, you'll get big drop all the way down to 1:18. Medium low, 42 seconds. Draft, we got 21 seconds. Draft low, 6 seconds. Low, 4 seconds. And obviously the noise becomes much more noticeable. And lowest is quite noisy image, but we only got it to a second and 44. So a second and a half. So between final high of almost 3 minutes all the way to a second and a half, just by adjusting the different sampling presets. And this is reducing the amount of noise threshold on the image and going to the max samples. So you can see there's a huge amount of difference by changing the thresholds. Obviously different scenes are going to react differently. The simpler scenes, you'll see in the last few settings there will not be a big difference because already the level of noise have already reached. They had stopped rendering any more samples. The sampling presets are really nice and convenient. They work consistently, but there are going to be scenes where you're going to have to do some changes to maximize what you will need to do for your scene in quality and noise thresholds. So you go to user mode, that this becomes active already, the sampling render section. It is recommended to use noise thresholds, which is adaptive sampling. For final render, definitely I think that is a good starting point to use the final presets, the default that comes out for final render. It is also recommended to use max samples. Small changes in thresholds, if I go from 0.01 to 0.02, are going to make big changes in the rendering time, especially for interior scenes or scenes that have relatively high noise. Normally you would increase your thresholds to improve your rendering time and not reduce your max samples. To take full advantage of adaptive sampling, you need to have your maximize, keep relatively high samples ideally, and then you control your rendering time by your noise threshold. If you reduce the max samples and keep your thresholds low, like at 0.01, then what you're doing, you're stopping the actual rendering early. So for example, in this scene, the areas for the window, the background, certain areas in the floor have little noise, so adaptive sampling may stop rendering, let's say at 1,000 samples. But other areas that have a lot of noise, adaptive sampling would continue rendering all the way up to your max samples. So that's the way you'll save rendering time, based on that noise thresholds and stopping the rendering and have reached the level of noise reduction that's required by the noise threshold set. In this case, if you want to reduce rendering time, you need to just keep increasing it gradually until you reach the level of rendering and noise that is acceptable for your scene. So you go to basically 0.3, probably going to go to 0.5. You can move all the way up to 0.1. So basically you keep going all the way up to basically you can reach all the way to 1, which is the max. But in some scenes, especially interior scenes that have a lot of noise in dark areas, adaptive sampling cannot be increased, or the noise result cannot be increased without creating some artifacts I call blotches. In those cases, we need to reduce the noise threshold. And let me show you an example. Noise thresholds at high levels create problems. So I've loaded here this scene by Identity Design, called Dark Interior, sampling section and noise thresholds 0.05. Let's do a test render. So I finished rendering this image at 0.05 threshold at 4096 samples. But if you look closer at this scene, you'll see all these blotches, especially in the dark areas. That's a problem because the thresholds are relatively high for that area, and we'll see the time of 1:53. In this case, if you want to maintain the same rendering time, you need to the threshold until the blotches disappear. At that point, you can start reducing samples. I did this test for this image and I reduced the threshold all the way to 0.005 and use 1,024 samples. You see, and now all the blotches are gone. You may have slightly more noise in certain areas, but there's no more blotches artifacts, and the time is pretty much even a little bit less than the one that we had previously with all the blotches. So this is that time or since that you need to, your noise thresholds until blotches are gone, and then you start reducing samples. The rendering time is acceptable in noise level for your requirements. So now we're going to be looking at denoising. Denoising is quite important, especially if you want to reduce your rendering time or you want to improve the quality of your denoising for a cleaner, sharper image. Ultra Denoiser is based on the Odin Intel technology, have clean, sharp looking images at very low samples, save you rendering time. Look at some of the options and features. So clicking Ultra Denoiser will enable multipass, will give you the highest quality. First start doing it without multipass. Similar results to what you get with a regular Odin Denoiser from Blender. Typically you want to use denoising input passes of albedo or normal to give you the most information to do a better denoising quality. Prefilter for high noise, low samples, want to be using accurate. Quality samples or final rendering settings, you want to be using none, because it doesn't do any pre-filtering, so you'll have a cleaner looking image. So let's look at these settings in a low quality rendering samples. Pick lowest, will give us the most noise, so we can actually see the changes that these settings have in effect. So here are the results with the different pre-filterings: none, fast, and accurate. None, the problem is no pre-filterings that will get areas where the denoiser doesn't work. And as you can see in this area, there's a few other areas where you have extra artifacts from the denoising. Fast, a reduction of those artifacts. Accurate, you see it cleans up those artifacts completely. With fast, you also have more blurry. The texture on this wood is blurry than accurate. Maybe not easy to notice in YouTube, but slightly more detail in accurate than fast. For low sample rates, you want to be using accurate pre-filtering. Test the multipass option, which allows you to bring a lot more detail in your textures, the quality of the geometry. Two modes: one is multipass if you have glass, like on glass. In this case we do have some windows, so we want to use transmission, and if you have volumetrics you want to enable it. It'll save you a little bit of time. If you don't have volumetrics, no reason to have it on. It'll save you some time. We have individual passes, which can give you a slightly better image quality. That'll take a little longer time. Notice each data pass individually. And if we look at the data passes, all of these passes, these ones get denoised individually, so they're ready to be used in the compositor, and it's done before that compositor. So you'll have all clean light data passes, all individually denoised by this option. Potentially higher quality denoising, but it'll take more time. So let's look at these two options and see how they work. Keep the pre-filter accurate, and let's do some test renders. Finish rendering the multipass and multipass individual. Look at the image and compare with the previous accurate settings that we have. So if we look at, look at this corner, we click on multipass. A lot more detail on the textures, on the edges of the book. This is accurate, default denoiser. This is multipass. See a lot cleaner textures, cleaner edges on the books, geometry. See that textures, more detail. Let's look for accurate. This definitely blurry, nice sharp texture detail. Look at the geometry. Let's look at accurate. So the light switch are pretty blurry. The corner of the wall is pretty blurry. As soon as I hit multipass, we have nice edge on the wall that's defined, and a cleaner looking geometry on the light switches compared to accurate. So zoom in, accurate, relatively all blurry. Multipass, much sharper definition. And multipass individually may give you a little bit quality in certain areas, like here. You'll have the shadows, the shadow areas came into play where they're not before in multipass normal. So you have a little bit shadow areas. Texture detail are going to be really, really similar. Multipass individual, multipass, so slightly better definition. And the advantage of multipass individually is that you'll have nice denoise passes to use. Time, you can see that took 12 seconds. Multipass took 11, so even for an extra second. From compared to accurate, it did take a couple seconds, but you'll get a lot more detail in textures and a cleaner geometry and shadows, so it's definitely worth it in low render samples. Or even a higher sample, you still get a cleaner image. We can look at the passes with a multipass, where you can go into diffuse, and these are all nicely denoised. You can compare with other individual passes. That's what you get. So it's a big difference in having every single pass denoise for later processing in your compositor. Here, glossing direct, multipass individual. So everything is denoise every single pass for later use. Covered all the major areas to improve performance in cycles, how to take advantage of the K-cycle performance features, how to properly use the Ultra Denoiser, properly use thresholds and adaptive sampling for rendering, new presets for convenience and ease of use. So thanks for listening, and see you next time.